Hello everyone. As I have been already introduced, myself Vikas Dwivedi. So I am going to continue with chemistry classes with you guys. As I was already saying, chemistry as a subject in JEE, you see, if you have learned the subject well, if you have understood the concept well, it will be very much scoring for you guys. As we have experienced in our preparation, if you do it well, chemistry becomes very scoring because the time you are going to allot in the exams will be less in comparison to mathematics or let us say physics. So, and one more thing which I have experienced during my preparation and what I understand is, okay, loudly, okay. So what I have understood is while preparing chemistry, generally, as you might have seen some web series also, something like that, that it is being projected, it is being projected as chemistry being a subject, which is kind of rote learning subject. You have to memorize something out of it, as mathematics being projected. Not able to listen? Okay, a bit more loud. Now I'm audible? Audible enough? Okay, I'll try to be loud, yeah. Louder, sir. How much louder? Wait. Now, am I audible to everyone? Is it good? Is it good now? Yeah? Yeah, we'll come to acidic radical, basic radical, everything will come to that. Yeah. Now, is it okay? Or still I'm not audible? Okay, thank you. Okay, so as I am saying that, chemistry as a subject becomes very scoring while preparing the JEE. Right? Why it is scoring in nature? First thing, it is not going to require too much of time in the examination if you have understood the subject well. So one thing, definitely it helps in the exam. Second aspect of the chemistry is, as it is being propagated, which as a teacher of chemistry we never like, and I may assume some of you student also would have too much interest in chemistry, some of you definitely have. So we don't like that it is being said that chemistry is a subject of rote learning, you have to memorize this and that. Nothing like that. If you start, with good foundation, good understanding of the subject, you are definitely going to love the subject. 110%. You'll fall in love with the subject. That is how the chemistry is. But the important thing is, if you understood the basics. So that is what actually we are trying to do over here. In the bridge course, that is the whole thing, that you understand the basics. For example, I'll start with the very basic idea of the chemistry. Like, see, one thing is the preparation, what we are going to do to crack the exam. But in my understanding, if you simply, focus on the marks and marks and marks, that I'm going to score some marks. Marks may come, you may score few marks, but you'll never have love for the subject. You will never want to explore more of the subject. And if it doesn't happen, you may crack mains exam here and there, but advance, the nature of JEE advance is as such that we need thorough depth, thorough understanding of the subject, so it's very, very important. Very, very. So some of you love organic chemistry, even my organic chemistry, that is my favorite. Also, chemistry is a mystery. Definitely it is a mystery, but we are going to solve that mystery in the upcoming classes. That is the whole thing. Yeah. So chemistry is very easy. We'll come to that. You will see how easy it is. I'll ask few questions. You let me know. Okay. So as I'm saying, we need to have depth knowledge of the subject. Suddenly you will see there is nothing to do in terms of rote learning or anything like that. Okay. So I'll start with a very basic. Kind of question. All of you have studied in, high schools, 9th and 10th standard. What is matter? And in terms of matter, we have studied. What we have studied, element, compounds, atoms, molecules, this and that, right? Most of you are saying it is very easy subject, right? So can any one of you give me the difference between, let us say, substance and mixture? What is the difference between substance and mixture? Anybody could tell me that? Yeah, I'll teach very basic. I'll start, that is the whole purpose of the class. That is the whole purpose of the class, that we want to make your foundation very, very good, so that you don't suffer, in the upcoming JEE preparation. That is the whole purpose of the bridge course. Definitely. So don't worry about that. We'll keep it very, very basic, and you'll see we will evolve out of basic idea and we'll make it difficult over the period of time. Anyways, I'll repeat. So what is the difference between substance and mixture? Mixture is a combination of two or more substances. Very good. Mixture is a combination of two or more substances. Now, I want to know the difference between, let us say, element and compound. Let me ask one question with you. What do you think nitrogen? If I'll ask you nitrogen, let me write. So let us say we are having nitrogen. So my question is, nitrogen is what? Element, or it is a compound, or it is a molecule, or it is an atom? What do you think? What is nitrogen? All of you have studied, right? What is element? Nitrogen is an element, compound, molecule, atom. What it is? Some of you are saying molecule, some of you are saying compound, some of you are saying atom, right? Okay, so there is molecule. Okay, so this is one basic, some of you are saying atom, molecule, most of you, some of you are saying element. So, you think, okay, there are two nitrogen atoms, right? So it will become a molecule, but actually nitrogen is an element. So this is one basic idea, it is an element. Very good, some of you are saying, definitely it is an element. So we'll try to cover all the basics, and we have few very good questions in the class today. We'll try to explore all those basic problems, and we'll see how to start with matter, and then we will go ahead with the structure of atom. So the first class will come to mole, and everything will come to that. Okay, starting with the classification of matter, as all of you can see. So what we are going to learn in today's class, classification of matter, and in classification of matter, what are the objectives we are going to fulfill is classify matter as substance or mixtures. So the first thing we are going to do, matter in two parts. Matter will classify into two, which is first mixture and substance. So first basic classification we are having, that mixture and substance. Okay. After that, we will try to understand what is the difference between homogeneous and heterogeneous mixture. So in mixture, again we will have two parts. We'll come to the next slide, I will show you there. Mixture again have two parts, which is called as homogeneous and heterogeneous mixture. So what is the difference between homogeneous and heterogeneous mixture? We'll come to that also, with very interesting concepts. And then we will see in what ways we can understand the substance. Again, substance has two classifications. Substance also is classified into two parts, right? Generally, it is being said that mixture is impure in nature, generally. In some books you might find it is written as it is an impure substance. Mixture is an impure substance. And substance ko simply we say it is a pure substance. Sometimes you will find impure substance is also written as mixture, right? Okay. And then last, you'll understand how to categorize elements and compounds. Let me go to the next slide. So what is matter? Let's start with the basic definition of matter. Matter is anything which occupies space and has mass, right? All of us has understood in class 9, very basic idea of matter. So matter includes everything which we are able to see, touch, or something which we are not able to see and touch. Everything, let us say whatever is present in universe, is nothing but matter. Whether we are able to see or we are not able to see, whether we are able to touch or we are not able to touch. For example, you say it is being said in culture, Panch Bhutas, 5 elements on which the life depends. All the life on this planet depends on the Panch Bhutas, 5 elements. For example, what? Sky, Akasa, as it is being said. Fire, Agni, yes. And what is that? Earth, water, right? So we are having 5 elements which are called as Panch Bhuta. Everything is what? Matter. So something which you can see, touch, and something you can't see and you can't touch. Everything, whatever comes in the universe is known as matter, right? Now, let us go to the next topic, next slide, and see what do we have. Now, so see, we are classifying matter. As I already said, matter could be classified into two parts, broad category. One called as mixture. I hope this slide is visible to all of you, right? Yeah, notes will be given to you, don't worry. Notes will be given to you. Is this slide visible to everyone? Yes, thank you. Okay, so matter could be broadly classified into two parts, as we were saying, mixture and substance, right? So now we are having mixture, two classification again, as I said, homogeneous mixture and heterogeneous mixture. Now, in a few state examination, I have seen few questions, that is why I'm having this particular slide. Now you see what is written over here. Mixture and substances could be separated by physical methods. So this is what is written over here. That this is very, very important. Questions has come from this. That mixtures and substances could be separated by physical methods. Can you give me an example? Can you give me an example where we can have mixture and substance and we can separate that? One example, we'll take one example. Let us say that, not clear, no, don't worry. So this left hand side we are having mixture and the right hand side we are having substance, right? So matter ka broad classification, mixture and substance. As most of you have already said, substance is pure in nature, right? And once you add two or more than two substances, what do we have? Mixture, right? Now, mixture and substances could be separated by physical methods. And substance which is broadly classified into compounds and elements could be separated by chemical methods. This is very, very interesting. Yes, air is a mixture, yes, definitely. So, tell me about this. I am saying substance in which we are having compounds and elements could be separated by chemical methods. Could be separated by chemical methods. What is that? So, let us understand what is compound and element, and then we'll come to the chemical separation, and then we will come to the physical separation. Let us understand this one. So, let us understand element and compound, and then we'll come to the substance and mixture. Yeah, hand picking and filtration, very good, we'll come to that. So, compound and element. What is element? So, element is something which is non-divisible, right? You can't divide that further. For example, we know, for example, let us say iron is an element, right? Magnesium is an element, right? Calcium is an element, right? Yes or no? Now, we say that hydrogen. For this, hydrogen, H2, or let us say oxygen, O2. For this, we need a proper definition of element. Not just this, that it is non-divisible. We need to know something more about element. So, element is something which has only one type of atom. This is very, very important. If you want to note it down, you can note it down. Element is something which has only one type of atom in it, not more than one. One type of atom. Now the confusion comes. What is the difference between element and atom? What is the difference between element and atom? Anyone? What is the difference between element and atom? Yes, elements contains only one type of atom. Very good. I'll try to write neat, don't worry. Okay, let me raise it. Anyone, please give me the difference between element and atom. What is the difference between element and atom? Atom is the smallest unit. Atom is the smallest unit. I'll write neatly, don't worry. My handwriting is not very good, but I'll try to make it good for you. I'll try my best. Smallest particle of element is atom. Very, very good. So, atom is the smallest unit. Atom is the smallest unit. For example, let us say if I have this gold ring, right? Now, this gold is an element or atom. So, this is an element, right? But this element will have one fundamental particle, right? An element will have fundamental particle. If you are able to understand that fundamental particle, you should be able to define the whole element. Are you getting my point? What I'm trying to say is, in this classification, we can write about, so let's see, compound fundamental particle as well as element fundamental particle. FP means fundamental particle, while an element is a pure substance made up of one type. Very good. So compounds fundamental particle. What is the fundamental particle of compound? So it is nothing but molecule. This is very interesting. And what is the fundamental particle of element? Fundamental particle of element is atom, right? What do you mean by fundamental particle? Fundamental particle is such a particle, right, through which you can define the element, right? So atom being fundamental particle. As I was saying, let us say we are having gold. This is an element, but it will have one smallest unit of it, which will be called as atom. So if you are able to understand one atom, you should be able to understand the element. Now come to this one. Compound fundamental particle is molecule. If you are able to understand one molecule, you should be able to understand the whole compound, right? Okay, so let us come to this. We'll take few examples of molecule and compounds. Let us say element, this element is going to produce compound, right? Let me take one example. I have taken hydrogen and I have taken oxygen. So hydrogen, again, as the definition says, what are the definition of element? Definition of the element is it has only one type of atom, right? It has only one type of atom. Similarly, oxygen being element, again, because it is having one type of atom. So I'm writing H2 plus O2. Now it will give what? H2O, right? So element, right? They combine and form one compound, which is water. So element ka combination forms a compound. Therefore, we are saying that their separation could be only done by chemical methods. Let me come to this. The separation could be only done by chemical methods. What does it mean? Separation could be done only by chemical methods. What is the meaning of this? Now, let us say we took hydrogen and we took oxygen and we reacted them together. Hydrogen and oxygen react and form water, right? Now, if you take the water, can you remove hydrogen and oxygen separate? Is it possible? Can we separate them? Electrolysis. Now, electrolysis, what is electrolysis? Electrolysis is a chemical process, right? It is not a physical process. Yes, it is a chemical process. That means if you want to separate compound from element, it should happen with the chemical methods, right? The separation should happen with the chemical methods. Great. Yes, electrolysis, that is a chemical process. You can't separate by physical processes. Very good. Now, come to this one. Now we are going to understand how to separate substances and mixture. So as I said, how to separate substance and mixture? With the help of physical methods, right? Now, give me one example of mixture. Give me one example of mixture. Let us say we are having sugar or glucose, whatever you want to say. Let us say that we are having sugar and plus we are having water. So if we add sugar into water, right, we are having a mixture. Sugar and water, we are having a mixture, right? Now, how can we separate sugar and water? Initially, you took the sugar and you dissolved into the water. You did the dissolution process. Now, do we need any chemical method to remove sugar and water? No, right? What you have to do? Boil. Simply boil the solution. Boil the mixture. If you do the boiling, what will happen? Water will come in form of steam, right? Water will come in the form of vapor. You can condense it, right? Evaporation, very good. So if you do the evaporation, water has come into the form of vapors. What is left? Left is what? Sugar, right? So you can separate mixture and substances with the help of physical method. This is very important. So you can separate with the help of physical methods. And elements and compounds could be separated by chemical methods. Element and compounds could be separated by chemical methods. I'll repeat. Compound का fundamental particle. What is the compound fundamental particle? Molecule. Compound fundamental particle is molecule, and atom is the fundamental particle of my handwriting is not very good, but I'll try my best. Okay, so fundamental particle atom. Now, atom will combine and form the molecule. Right? This is the beauty. You see, element, fundamental particle, atom. Atom, combination of atom form molecule. And molecule is the fundamental particle of compound. So, with the help of atom, we can have element. And with the help of element, we can have compound. Or, with the help of atom, you can form the molecule. And because molecule is a fundamental particle, and if you understand that, you can have compound. Let me take one example, as I have taken already. H2 plus O2. So H2 and O2 both are elements, right? And what do we have formed? With the help of elements, what do we have formed? Compound, right? Okay. So now coming to the classification of mixture into homogeneous and heterogeneous mixture. I think all of you know what is homogeneous and heterogeneous mixture. Homogeneous mixture is something, right? If we again take the example of sugar plus water. If you add sugar into water and if you shake it well, you make it proper, solution, what will happen? If you taste that solution, right, from the top, you will feel the same thing, right? Same amount of sugar. Similarly, if you go to the bottom side of the solution, you will have the same taste, right? Taste is not going to change. That means there is uniformity in the solution. Yes, that is called as homogeneous mixture, having uniformity in the solution. And let us say we are having iron. Let us say we are having small iron particle or needles, and then we have put it into the soil. I have one figure for you. Okay. So again, this is the definition. I have kept it here for you. You can go through it. What is substance? Substance is a form of matter. You can go through it. That has a definite composition and has distinct properties. Example, water, ammonia, etc. We have already understood this. Yes. And what is a mixture? Mixture is combination of two or more substances. Right? Substance is a form of matter that has definite, constant composition and distinct properties. Right? And here we are having mixtures. Okay. Now we were discussing about homogeneous and heterogeneous. So the mixture in which the composition of the mixture is the same throughout. That means uniformity. There is uniformity in the mixture. Those kind of mixtures will be known as homogeneous. And if you're not having uniformity throughout the solution, that means heterogeneous. I'll take one example over here. You see this one. So what is this? These are the iron particles. I hope it is visible to you. These are the iron needles, small needles, kept into the soil. Right? Now, this is a homogeneous mixture or heterogeneous mixture? So this is a heterogeneous mixture. Right? Heterogeneous mixture. And as we were discussing, so one is iron and one is soil. So we are having two substances. Can we separate them? With which method? Definitely. With which method we can separate them? With which method we can separate them? Iron fillings, yes. Yes, I'll send the notes in PDF form, don't worry. With the help of magnet, we can separate them, yes. So see, we are having a magnet over here. You can see, all of you can see. We are having a magnet, right? You put the magnet over here, you see, all the iron fillings are towards the magnet, right? I'll send the PDF, you can look to the definitions, okay? Okay. Now, coming to the elements and compounds, which we have already discussed. Element is a substance that cannot be separated further into simpler substances by chemical methods, right? Compounds. Compounds are substance composed of atoms of two or more elements, right? Chemically united in fixed proportion. Proportion will come in detail. There are different laws to define proportion that we'll discuss tomorrow, right? Okay. So we are having a question over here. Which of the following diagrams represents element? If we have understood, element and everything, I want to ask you this question. Which of the following diagrams represents elements and which represent compounds? Color given, each color sphere represents an atom, right? Different colored atoms indicate different elements. Now let us have the question. Okay, so this is the question we are having. You have to answer A, B, C, D. A, B, C, D, we are having 4. You have to identify that among A, B, C, D, which is the element and which is the atom. Read the question. Different colors represent different atoms. Right? What are the spheres you are having? All these spheres. Different color, different atoms. So you have to tell me which figure among A, B, C, D represent element and which represent compound. Okay. A, B elements. Actually in A, I think you are not able to see. Let me see. Okay. I think it is not very clearly visible, but this blue one, blue sphere, behind that there is white balls actually. White spheres are also there. I don't know if you are able to see. C represent compound. Yes, definitely. C represent compound. Let us look at this. C represents compound. Right? So we are having one green and one red. Right? Very basic example we all know. This is nothing but, what is this? Water. Yes or no? This is H2O. One is oxygen element and two are hydrogen. Right? So what is this? This is compound. Very, very good. So this is compound. If you look into the D option, right? If you look into the D option, what is it? These are all yellow ones. Now, there are 4 to 5 yellow balls. 4 to 5 yellow balls. Now, if you have 4 to 5 yellow balls, does it become molecule or anything like that? No, right? 4 balls, as I have said repeatedly, element is something which contains the same type of atom. Right? So this will be also, most of you are giving the correct answer. So this is also element. Very good. Element is D. Yes, D is the element. B is also element because it is having only one color. C doesn't represent element. Who is saying? Dipti, how come C represents element? How come C represents element? Huh? It is having different colors, right? And we have already said when color combine, different colors, you'll have a compound, not the element. A, I think it is not visible to you guys, but A, behind A, there are the white balls actually. These yellow ones, actually I think you are not able to see. These white balls are there. What about A? Yes. So basically, I think it is not visible to you guys. Actually, this is the blue one. Behind the blue, there are white ones. White ones. So in this one, this is the example of actually ammonia. I don't know if it is visible to you guys. There are 3 white ones which are behind the blue ones. So this is also compound. Yes, very good. A is also compound. So A is compound, B element, right? B is element. C again compound, and D is element. I hope it is clear to everyone, right? I hope it is clear to everyone. A is compound, yes, A is compound. Explain D. Okay, I'll explain. So let us take one more example. Let us say that, what about O3 molecule? All of you know O3, right? Ozone. All of you know ozone, right? O3. So what is O3? Element. What is O3? Yes, as D is element, yes, as all are same type of atom. What is O3? O3, element, molecule. What is this? Ozone, what is this? Element. Very, very good. Most of you are saying element. Yes, because again it contains same type of atom. I think all of you know, right? C60. Buckminster fullerene. I think all of you know, right? Buckminster fullerene. What are you going to call? Buckminster fullerene. C60. What is this? Element, What is this? Molecule. No. In D option, there are no white dots. No white dots. A is a compound or no? Yes, A is a compound. A is a compound. There are white balls which is not visible to you actually. Yes, very good. A, C60 is also element. Very good. Yes, very good. Element. So, I think this is very clear to us. Very clear to us that element has same type of atom. I think it is very clear to everyone, right? It is allotrope. Yeah, definitely it is allotrope. Yeah, allotrope. Different form of same element. Yeah. Very good. Okay, so let us go to the next slide now. Now we are coming to the 3 states of matter. I think all of you know 3 states of matter. Molecule is something which is having more than one type of atom. Actually, I'll tell you, in some books you will see, for example, O2. O2 is sometimes written as elemental molecule. You don't call it simply molecule. If you want to call it as a molecule, you say it is an elemental molecule, not the molecule. Molecule is H2O, which is the fundamental. If you have too many water molecules, water molecule, if you take molecule, so it is a basic unit. Basic unit of what? Fundamental particle of what? Compound. So water is a molecule which is the fundamental particle of compound. Okay, I'll start with the new topic now. If any one of you have doubt, you can ask tomorrow. 3 common states of matter. What are the common states of matter? I think all of you know that, right? Solid, liquid, gas. Anybody knows any other states of matter? Any other state of matter? Anyone other than solid, liquid, gas? Any other state of matter? Solid, liquid, gas? Other than that? Any other state of matter? Yes, very good. Bhuvana, very good. Actually, we have a student, Bhuvana, in our class also. Very good. Plasma and Bose-Einstein condensate. Very good. You guys are talented. Plasma and Bose-Einstein condensate. Yes, very good. Okay. So, 3 common states of matter are, I'll take this example with you guys. So, this is the microscopic view of solid, liquid and gas. I hope it is visible to all of you, right? So, this one, if you see, this is in the solid form, right? Now, there is a chapter in class 12 will study, will come to the solid, liquid, gas, plasma and Bose-Einstein, will come to that. So, you see, this is the solid. Now, you look at the representation, microscopic view of a solid. How solids are arranged? You look at the arrangement of the solid. Yes? That is wrong. What is wrong? Little kids could answer. Yes, I know some of you are very talented, right? If I'll start asking questions, difficult ones, you won't get any answer. So this is the whole thing, right? We want to clear the basics of all the students who are coming from other boards, CBSE or anything like that. Don't worry. Abhi, from tomorrow we'll come to all the difficult ones. Don't worry. Then you'll have problem. Don't worry about that. Let us stick to the basics so that we can understand the difference between molecule and compound. What is the difference between element and atom? Atom is the fundamental particle of element. Similarly, molecule is the fundamental particle of compound. Okay, so I think this is visible to everyone. So this is the solid arrangement. All the atoms are very closely placed. You see? All of them are closely packed. Yes, very good. And look at this. Once solid convert into liquid, now you see there is some distance between them, right? Now in the solid, the movement of atoms, in the solid movement of atom is very difficult, right? Because they are so tightly packed. We'll study a chapter known as solid state. In 12th class, we'll study a chapter known as solid state. There we will evolve this topic of solid. How they are arranged, what are the kinds of arrangement it can have. We'll come to all those things, right? So solid state, and then we are having the liquid state. In solid state, yeah, you can't have motion of the atoms because they are so tightly packed. And then we are having the liquid. In liquid, solid state is not deleted from advanced, it is only deleted from mains, right? In advanced, still we have solid state. Okay, so in the liquid, you see there is some spacing between the particles or the atom. Yes? There are some distances between the atoms. So they may move little bit freely, not totally, but little bit they may have the movement. We'll come to what is Bose-Einstein condensate, we'll come to that. Okay, and then we are having the gases. Look at the gas. In gas what we are having, you see, now in the gas, the particles are able to move freely, totally, movement is free. So this is the difference between solid, liquid and gas, right? Okay, so we are having one example over here, 3 states of matter. So we have taken liquid water. Liquid water we are having, you see the molecules are drawn over here, water molecules, H2O molecules, the liquids are there, right? Now, the 3 states of matter, a Bunsen burner changes ice into water and water into steam. So now you see, we are having Bunsen burner and we have kept ice over here. Yes, so this is the arrangement of ice, I think all of you can see. So ice is being burned. Once we are burning the ice, it converts into liquid, right? And liquid goes into gas, you see, vapor form. So this is, you see, the water molecule is not broken. We have not broken H2O. I hope all of you understand. H2O is not broken into H2O and O2, right? Initially, water was in solid phase, converted into liquid phase and goes into vapor phase. Right? Now we are going to discuss, triple point of water, great. Now we are going to discuss something which is very, very interesting. Now, we all know solid converts into liquid, right? And liquid converts into gas. Now, there is some temperature, right? There is some temperature. We're coming to that. There are 5 states of matter. We are coming to that. Solid, liquid, gas. We'll come to that, Betaji. We'll come to that. So let me define. So we are having solid, liquid, gas, and if you keep on hitting very high temperature, very high temperature, very high temperature, if you keep on increasing the temperature, what will happen? Actually, you will have particles which will have very, very high energy. You know, if you want to go into the depth, I don't want to go much, but anyway, if you are asking, what is the fundamental particle of matter? What is the fundamental? What is the fundamental particle of atom? Rather matter we will say. What is the fundamental particle of matter? Van der Waals forces, actually it is hydrogen bonding, which is a bit stronger in comparison to Van der Waals forces. Atom is the fundamental particle? Some of you are going into much depth, Bose-Einstein and condensate. What is the fundamental particle of atom? Fundamental particle of matter, not atom, go more in depth. Go more in depth. Yes, one is electron, proton and neutron, definitely. Quarks, somebody said quarks, yes. So there is something called as leptons. I don't want to go because it is not needed for us much. Leptons and quarks. So these are the fundamental particles of matter actually. But in our syllabus not needed for us. We'll simply stick to atom. And atom ka fundamental particle will be electron, proton and neutron. So we'll stick to that only. Okay. Now, we were discussing about if you heat the gas to very high temperature, the particles will have very, very high energy. Very, very high energy. Right? And they are known as plasma. Anyway, plasma, and if you condense, if you keep on condensing, solid will become, atoms come so close to each other, actually they act as superatom. You might heard, fluidity, superfluidity, right? Okay, so solid will actually go into Bose-Einstein condensate. If you keep on decreasing the temperature, if you have very, very low temperature, this will convert into Bose-Einstein condensate. Basically, it becomes superatom. It is being said that it becomes super. It has too many applications, but we are not interested into that right now because that is not part of our syllabus. We won't go into that. Okay, so right now I want to stick to solid, liquid and gas, and I want to discuss something which is called as freezing point and boiling point. So please define me boiling point. All of you guys, define me boiling point. Define boiling point. Define boiling point. Define boiling point. 100 degrees Celsius, is it boiling point? The temperature at which the liquid changes to solid. Liquid change. I'm asking about the boiling point, beta ji. Boiling point. Liquid changes to solid is boiling point. The temperature at which we can boil a particle. No. The boiling point which a substance transforms from liquid phase to the gas phase. Yes, we are having one definition. From the liquid phase to gas phase. Yes, that is one definition. Right? Okay. So, yes, that is one aspect of it. So, that temperature at which liquid can be converted into gas. 1 second, guys. Okay. So, let us come to the boiling point now. The temperature at which liquid can be converted into gas. Now, if this is this topic which I'm going to discuss right now, the boiling point is very, very important. There is a chapter in thermodynamics known as entropy, right? Very, very important. Listen carefully. So, that will be my question. We'll discuss this concept tomorrow. This is my question. Listen to me, guys, carefully. So, if you are saying boiling point is that temperature at which liquid converts into vapor, right? Right? If that is the concept we are having, then you have the lakes around you, right, which contain water. And the maximum temperature which we can achieve into that, how much? Room temperature, maybe 30 degrees Celsius. If you go to the northern parts of India, how much? 40 degrees Celsius, right? Now, that is the temperature, 40 degrees Celsius. Now, in summer seasons, you might have seen all the liquid goes into vapor, There is no water anymore in the lake. So, temperature is how much? 40 degrees Celsius. Now, is 40 degrees Celsius boiling point? All of you know the boiling point of water is 100 degrees Celsius, right? So, we know that at 40 degrees Celsius also, all the water converts into vapor. Is it boiling point? No. You leave the, water, let us say 20 degrees Celsius. At that temperature also, after a certain time, you will see all the liquid has converted into vapors. Is it boiling point? Is it boiling point? You can have 400 degrees Celsius, all the liquid will convert into vapor. Is it boiling point? If this is the definition, that there is a temperature at which all the liquid will convert into vapor, so the temperature could be anything. 20, 40, 50, 60, 100, 400, 500. Is it boiling point? So that is what I am saying, no. Point in which liquid and vapor, liquid converts into vapor. Whole mass of liquid, yes, whole mass of liquid. Let us come to that. You have, let us say, 100 grams of water, everything converts into vapor. Maximum temperature, is it so? Then how come 100 degrees Celsius? The temperature at which the transition from a liquid to gas. That is what I am saying. Even at 40 degrees Celsius, you can have transition. Is it boiling temperature? Is it boiling point? Yes, boiling may happen, the temperature less than the boiling point. Yes, all may be converted into vapor. So what is the boiling point then? Why we say 100 degrees Celsius is the boiling point? Anyone of you have the idea? Anyone has the idea? Because the water is kept constant heat, then temperature increases, this water. No. The temperature at which the substance starts boiling, no. At any temperature, water can be converted into vapor. All water, no. Completely changes into vapor. That is what I am saying, no. At 40 degrees Celsius, all the liquids can be converted into vapor. No. So none of you are having answer. We'll discuss it tomorrow. This is very, very interesting concept. Yes, the boiling point of a substance, the temperature where the liquid turns into vapor, okay, the comment is gone, wait. Equal to atmospheric pressure, yes, that is one definition. Water equal to the surrounding atmospheric, yes. We'll come to that definition tomorrow, I'll discuss it in more detail. Now coming to the physical and chemical properties of matter. We'll discuss the boiling point tomorrow, it's very, very interesting concept. So what is the physical and chemical properties? A physical property can be measured and observed without changing the composition or identity of a substance. Yes. For example, just now we saw we have the water in the container. Initially we have ice, right? Initially we are having, let us say, ice. And then if you start heating the ice, goes to water, right? You are having liquid now. Then liquid converts into vapor. Yes. The composition remains same. Water has not broken, right? Water remains as H2O. The molecule remains as H2O, right? So the physical property means a physical property can be measured and observed without changing the composition. So in this boiling, we have not changed the composition. Composition remains same. What is that? 2 hydrogen atoms and 1 oxygen atom, right? 2 hydrogen, 1 oxygen. Are we changing their composition? No, we are not changing their composition. So it can be observed without changing the composition or identity of a substance. So water remains as water, right? If you have the vapor, you can condense the vapor into liquid. Liquid can be condensed to solid, right? So we are not changing identity. This is very, very important. We are not changing identity. What are the examples of physical properties? Color. Color is physical property. You can observe, right, without changing any composition. Melting point, boiling point. These are physical properties. Refractive index, physical property, right? So this is the definition. Physical property can be measured and observed without changing the composition or identity of a substance. Let us come to the chemical property. Chemical property can be observed by changing the composition or identity of a substance. So this definition is not very appropriate. Actually, chemical property is something, which you can observe only when there is some reactions are taking place, right? For example, we all know we are having hydrogen. Let us say we are having nitrogen gas. Let us say we have nitrogen gas. Let us say we are having nitrogen gas and we are having hydrogen gas, right? Nitrogen plus hydrogen. They react together and they form ammonia. Now, what happens in chemical property is nitrogen and hydrogen has lost their identity. There is no nitrogen anymore and there is no hydrogen anymore. They have been converted to ammonia, right? We'll discuss everything, emission, absorption, spectra. I will come to that atomic structure. So nitrogen and hydrogen comes to ammonia. They have lost their identity. So that is what we are going to understand in chemical property. Now, physical property you can observe, but chemical property you can't observe as such. Only you can look at the product, right? So chemical property is related to what? Chemical property is related to what? That is my question. Before that, intensive, extensive. You see, this is very, very interesting. All of you know the basic structure of atom, right? Basic structure of atom, all of us know. What is the basic structure of atom? So, in basic structure of atom, we are having something called as nucleus, right? And then we are having orbit. This is the nucleus. And then we are having the orbit in which the electrons are evolving, right? The orbit in which electrons are evolving. Now, what defines chemical property? Listen very, very carefully. Chemical properties are defined with the help of electrons, right? So nucleus, this is what we are going to discuss in tomorrow's class, atomic structure. Nucleus is something which will never participate in chemical reaction. What will participate is electron. And this electron is going to define all the chemical properties, because actually electron is going to participate in the chemical reaction. All of you know, can you break the nucleus? If you break the nucleus, you have the nuclear energy, right? You'll, evaporate the whole planet with the nuclear bombs, right? So you are never going to break the nucleus for chemical reaction to take place. Chemical reaction will take place with the help of electrons. And this is our tomorrow's topic. We'll discuss it tomorrow. Now, in physical properties, matter, matter can have two kinds of properties. Other than physical and chemical, it can have two properties which are measurable and non-measurable properties. This is very, very important for thermodynamics. We'll study thermodynamics. This is very, very important. So we may have measurable properties and non-measurable properties. What is measurable property? Achha, give me a few examples of non-measurable. Let us say beauty. Now, can you measure beauty? How beautiful somebody is? Can you measure that? Is it possible to measure that? No. So that is non-measurable properties. So that is not the part of the chemistry or science, right? How happy you are? Is it measurable on some scale? Is it possible? No, not possible, right? So those are non-measurable properties which we are not concerned with. In case of measurable properties, we are having two types. One is called as intensive property and one is extensive property. Intensive and extensive property. What is intensive property? Intensive property is something which does not depend on how much matter is being considered. And extensive property, which are measurable, extensive property is something which will depend on the amount. I hope all of you got it. Extensive property, EX, depends on external condition. X depends on external conditions, right? Intensive property, IN, which is independent. So which is independent of the size or mass is known as intensive measurable property. And extensive property is one property which is extensive property which depends on the amount or size of the system, right? Let us take few examples. Let us say that we are having length. So length is extensive property or intensive property? Length is extensive property or intensive property? Tell me, length is extensive property or intensive property? Very good. Length is extensive property. Very good. Because it depends on the size. Let us say we are having one meter stick, right? And so this is very easy to identify extensive and intensive. Let us say we are having 1 meter stick and you cut it into half. Length remains same or changes? Length will remain same or it will change? It will change, right? Therefore, it is extensive because it depends on the size of the system. Let us say we are having temperature. What is temperature? Intensive property, extensive property. What about temperature? Temperature, intensive, extensive property. What is temperature? Intensive property, extensive property. Okay, some of you are saying extensive, some of you are saying intensive property. Intensive, extensive. Okay, most of you are saying extensive property. Okay, so think about it. Think in terms of temperature. Let us say we are having, a container, or let us say you are sitting in a room, right? You are sitting in a room. Let us say the temperature of that room is 25 degrees Celsius. Intensive, yes, very, very good, intensive. So always imagine like this. Let us say we are sitting in a room. The temperature of the room is 25 degrees Celsius. You change the size of the room. You make it half. If you halve the room, what do you think? Temperature will become 12.5 and 12.5. Is it going to happen like that? Or temperature will remain same? Temperature will remain same. If it was extensive, it would be very interesting, right? You take one bucket of water, it is a hot water, let us say 50 degrees Celsius, and you want to drink cold water. Summer times you want to drink cold water. What to do? Make it half. 50 becomes 25, 25. Again take the 25, make it 12.5, 12.5. Yes or no? Then it will become 6 degree. Not possible, right? So temperature is an intensive property, right? So I have a few questions for you. I'll send the PDF, it will go to you. Which of the following represents chemical and physical change? And then the next question is, determine which of the following properties are intensive and extensive. So these are the two homework, this one slide. So you have to tell me chemical change and physical change, right? And the next question is, determine which of the following is extensive and intensive property. One more question we are having. Which of the following, so this is PYQ question, previous year question from state, entrance exams, engineering exams. So which of the following statement about a compound incorrect? Can you give me the answer? We'll finish the class with this question. Remaining two questions you solve, we'll discuss it tomorrow. Can you answer me about this one? Yes. We are done. Just one more minute. Just give me the answer for this one. Which of the following statements about a compound is incorrect? Option 2, option 3, most of you are saying 2. Second option is incorrect. 4 also. 2, some of you are saying 3. Yes, 3. Very good. 4, 2. Okay. So most of you are, some of you are saying 3, most of you are saying 2 and 4. Okay. So the answer is third, right? A compound retains the physical property of its constituent elements, right? Compound doesn't retain the property, right? Thank you so much, guys. Thank you so much. We'll continue tomorrow. So tomorrow we'll start with the structure of atom. Thank you, guys.